right, sketching piecewise defined functions. Piecewise defined functions have different definitions for each piece. So for this one, when x is less than -2, the function that I'm interested in is y equals x. So that's what has to be sketched there. So you might be able to draw x, y very easily, but if you can't, then just do a couple of points, and when y equals x, then whatever x is, y is. So here I'll have -10, -10, -8, -8, -6, -6, and so on. And my line, which represents all the points that are true to that equation, would be this diagonal line. But that only would be the graph up to -2 and not including -2. So the point -2, -2 would be an open circle to show that it isn't really included, but be to the left of that, I would have this diagonal line. So I've taken care of the first piece of my piecewise defined function. Now between -2 and 0, my function is x squared. So let's figure out some points between -2 and 0. So -2, -1, 0. -2 all squared is 4. -1 all squared is 1. 0 all squared is 0. So my points are -2, 4, -1, +1, 1, 0. I have my parabolic shape. So here I'm going to draw it, but I'm not going to go any further because that only applies between -2 and 0. The endpoints are included, so I'm going to make them filled in circles. That's the second piece. The last piece says the function is equal to 3 when x is greater than 0. So 0, 1, 2. So the function is equal to 3, 3, 3, whatever the input is. So it's the horizontal line going through 3. It's when x is strictly greater than 0, so it actually doesn't include that point. So to represent that, I have an open circle and then a flat line here, arrow on the end of it to show that it goes on forever. And that's my piecewise defined function.